Well, welcome back to SanfordFlipMath. Again, this is calculus. This is section 2.1 in our book. We're actually on the second lesson from section 2.1, and we're again talking about limits. So this is 2.1b. Talking about limits, and again, the idea is as x approaches some value, some number, we want to know what the y values are approaching. So that's what this is about. Just a quick reminder that the easiest method for finding a limit is substituting. The only catch is it has to be continuous at the x value that you are interested in. Okay, sometimes that doesn't work, so maybe we'll look at a table of values. Very commonly a graph. Okay, most people can see it better on a graph. And sometimes we can do some simplifying algebraically and then do substituting. Sometimes maybe it's a complex equation. I don't mean complex like imaginary complex, but you know, it's busy. There's a lot of stuff going on. Sometimes you can use the properties and look at little chunks of the function instead. And or maybe there are certain values that are already known when you do that. Okay. All right. Those are specific to polynomials, and those are the properties, and you can go back to 2.1a to get those, or consult your book. They're all in there. And again, I wouldn't get all freaked out about the properties. Basically, the intuitive idea is you can find limits by looking at the parts of what you're finding the limit of. Okay, so that's kind of the idea. Okay, well, what we're going to look at right now is kind of a big deal. Especially, this is especially important if whatever we're looking at is not continuous. So anything we're looking at discontinuities. Okay, so discontinuity, sounding it out is very helpful. All right, so what we're looking at is maybe we're talking about something like y equals, let's say x over x minus 1. Okay, so here's a little sketch. It has a horizontal asymptote at 1. You can see that by looking at the x divided by x. If you recall, it has a vertical asymptote at x equals 1 also. So there are two asymptotes. And this has a piece down here and a piece here. Now, if I was going to find the limit as x approaches 7 for this function, this equation, this doesn't have any discontinuities over here near wherever x equals 7 is. Okay, so I'm not really worried about that. I could do 7 over 7 minus 1, 7 over 6. It's continuous there, no big deal. The problem is, what if I want to do the limit as x approaches 1? Well, I have a little bit of an issue. It's not continuous at 1. Okay, so there's this big old discontinuity. There's this big old asymptote there, and so that's kind of a problem. Okay, so I'm not a big fan of that. So we have to come up with another plan. Well, so the other plan is, well, look at the graph. Okay, so let's do that. So as I'm approaching x equals 1, so here I am bugging along on this guy. Okay, this looks like on the left side it's going towards negative infinity. So it's going that way. Okay, on the right side it's going toward positive infinity. So then the question is, well, so what's the limit? As x approaches 1, the answer is what? What is y approaching? Well, I guess I could have an arm wrestling match and have them, you know, see whoever the winner is. But the problem is that there is no answer. There is no limit. Now, some books actually make the case that since infinity is not a number, infinity wouldn't give you a limit anyway. I think most people would agree, though, if it's clearly infinity from both sides, then you're good. But in this case, they don't match. Okay, so there's no limit for this, or we could say does not exist is a very common way to say that, and it's often abbreviated DNE. So this kind of a situation you can say does not exist. So what just happened? Why did it not exist? Well, it was because these are not the same. Okay, so I guess we need to look at what is this box about? Because this box is actually doing it for us, okay? And it appears I clipped the right edge of the picture here, and so I'm sorry about that, but we will fix it right now. Function f of x to the limit of this x approaches c if and only if the right hand and left hand limits at c exist and are equal. Okay, so this is a big deal. Notice this big ol' and. Okay, and this is really one big set. So in other words, this has to equal a number, this has to equal a number, and not only are they a number, they have to be the same number. Okay? So I'm going to just kind of scroll down a little bit and rewrite that a little bit. Okay? So the limit as x approaches c of f of x is only exists if and only if the limit as this, okay, and I need to hammer what this means. Okay, so this does not mean negative c. This means x approaches c from the left. Not just from the negative numbers. I mean, negative numbers are on the left, but it's really about, c itself could be a positive number, okay? And so this would mean from the right. Okay? I'm going to make up a goofy example. Okay, you ready? So here's the idea. I'm just going to do one graphically. Okay, here we go. All right, so let's first do one that should be fairly well, not. All right, how about do this? -4. Okay, let's do as x approaches -4 from the left, as x approaches -4 from the right, and then we're going to also do the limit as x approaches -4. Let me pull it back down just a smidge, okay? Because I want you to see the definition. And I'm going to ask one more related question, and that is f of -4. Okay? All right, very common to see these four questions asked all together. Okay, so here we go. Notice at -4, it appears that that is the 0 of this function. Okay, so this is a graph of y equals f of x. Okay? Okay, so -4, 0 is a point on this graph. Okay, so this says as x approaches -4 from the left. Okay, so here's -4. Here's the left of it. As I go from the left, not to the left, from the left, approaching that point, what y value is it getting closer to? That's a 0. Okay. As I approach this point from the right, not to the right, from the right side. So I got to get over here somewhere from the right of it. I don't need to be down here because that's not even close to it. I need to be near this point, going from the right. I'm going to this point. What y value am I approaching? 0. Okay, so now the question is, this thing exists if and only if these two match. Okay? If these two match. Do they match? Yep. If they do match, then that answer is the same answer. Okay? So from the left we're going to 0, from the right we're going to 0. Hey, as we're approaching -4, what are we approaching? 0. Okay? And then this last question asks a different question. It says, what actually is the y value at -4? This says if I put -4 in for x, what actually is that y value? Well, shockingly enough, it happens to be 0. Okay? It doesn't always work out that they all match there, but so the question is, when they all match, what's going on? Well, it's actually continuous. So if it is continuous, there's no break or anything, it's just one big smooth thing, it's going to be fine. It's going to be, they're all going to be matching. Okay? Now remember, you can rewind this, so don't freak out. I just want to go back to do a different question for this. Okay? All right, cool. Oh, this was -4, sorry. Let me fix this a little bit. Make that work. Okay, new questions. Okay, limit as x approaches 3 from the left. Three from the right. As x approaches 3. And what is f of 3? Okay, one question at a time. As x approaches 3 from the left, what are the, so I could start over here, but that's, I'm not even close yet. So as I cruise in, what y value am I getting closer and closer to? Looks like 1 to me. Okay. As I approach 3 from the right, so now I'm over here, I'm approaching what y value? I'm approaching 2. Okay, quick note here. It doesn't actually get to 2, and that's okay. It doesn't ask what is y. This question does not ask what is the y value at x equals 3. It says what y value is it getting closer and closer to. Well, as I'm cruising in here, I'm thinking about 1.5, 1.6, well, it looks like it's getting closer and closer to 2. So that answer is 2. Okay. The next question, this says, what's the limit as x approaches 3? Well, from what side? This is a two-sided limit because it does not imply a side. So this is a one-sided. This is a one-sided. This other one, two-sided. So that, and the rule above says that this only works if these bad boys match. They don't match. Okay, so what's the limit? Does not exist. Okay. Okay, one last question. This last question says, what actually is the y value when x is 3? Well, go to 3, and which one's filled in? That one, not that one. Okay, and if they're both filled in, then we have a problem. It's actually not a function, and that raises a whole bunch of other issues. That should not be the case for things that you're working on. Okay. All right, so f of 3 is actually 1. Okay. So there's an example where they don't match. The two-sided limit doesn't actually exist. Okay. So again, for a two-sided limit to exist, both sides have to match. All right, so here's a graph already ready to go. Okay. Let's do the limit as x approaches, let's do as x approaches 1. We're going to go from the left, from the right, as x approaches 1, not implying a side, and we'll actually do f of 1 also. Okay? All right, so from the left. Well, here's x equals 1. Okay, that line is x equals 1. Okay, so then the question is, what is y approaching? Because we approach it from the left. So as I go from the left, well, it's approaching 1. Okay, again, there's no point in coming over here. I mean, yeah, you can come along here and kind of do this, but then you got to pop up here, right? And then keep going. So it doesn't start mattering until you get close to 1. Okay? Not an issue until close to 1. So all that stuff that's happening on the left end of the graph, I don't care. Okay. Okay, so again, just a quick little note here. Coming in from the left, the graph, as we approach the x value of 1, y is also approaching 1. Okay? So that's 1 down. Okay? As we approach from the right, okay, as we come in from the right, approaching the x value 1, what's y approaching? Well, again, it's approaching 1. Okay, now stay focused on what the question's asking you. As we approach 1, okay, so this is a new question now. As we approach 1, which side? Again, this is two-sided. And for two-sided to work, these two bad boys have to match. Well, do they match? They do. So the answer is whatever this is, whatever that matching answer was. So there it is. Okay, so remember what this is asking. As x approaches 1, what does y approach? As we approach 1 from the right and from the left, they approach the same value, and that value is 1. Okay. Now this question is asking a different question. What is the actual y value at that point? That's what it's asking. Well, the y value there is actually -1. Well, how can that be, Mr. Sanford? Well, it's just not continuous. This is probably piecewise function of some sort. So it's just not continuous, and that's okay. That happens. Okay. All right. Quick little separate problem. I don't want to write everything because time is getting to be an issue here. Let's look at x equals 0. The left-hand limit, as x approaches 0 from the left, -1. Okay, so same kinds of questions that we did over there, just at x equals 0. From the right, we're approaching 3. These don't match, so the two-sided limit would be does not exist. And if we were going to do f of 3, or I'm sorry, f of 0, it happens to be 3 because that's actually the filled-in circle there. Okay, so discontinuities can have different kinds of results. You can have a limit and have a different y value. You could have a situation where there's no limit at all. There could be infinities involved. We'll deal more with infinities when we get to section 2, but that happens. Okay. All right, we have one other issue that we're going to try and get in here, and then we'll stop. And this is kind of weird, and we will talk more about it in class and maybe do another example next time, we'll see. But what this is saying is if you have some function that is between two other functions, okay, so if this is functions that have y values, okay, and if it's between two specific other functions that you can nail down, then you can actually find its limit at some x value c if this limit and this limit, this is the above, this is the below limit, if they both equal the same thing. Okay, now again, that sounded like a lot of stuff to say. So let's look at a quick example, and then we're going to be out of here. Okay, so let's say x is approaching 0, and we are doing, let's do 1 over x times cosine. This is going to be a bit of a problem. Okay, so let's do 1 over, I need something that I can't just put this into. No, that's not going to work either. Ah, that was like magic, wasn't it? Okay, please note the equation just changed. Sorry, I had it switched around. All right, so this is kind of an ugly mess. Now, here's the issue. If I think about the properties, I could maybe think about the limit as x approaches 0 of x, and the limit of x as x approaches 0 of sine of 1 over x, and kind of do those separately. But it's still, the problem is when I look at 1 over x, whoop, hello, that was funny. When I look at 1 over x and try and put 0 in there, that's a bit of a problem. Okay, so I can't do that. So I can't do the little cute substitution thing, that I wanted to do, even looking at the properties. Okay, so this says if this whole thing can be shown to be between two other functions that have the same limit, they don't even have to be this function, they need to be some function that has the same limit as each other, then I can find this limit in between them. Okay? The idea is that I have some function up here and some function over here, and somewhere along the line they come together, and so if the function I'm actually looking at, if they all come together at the same time, if I can calculate that limit, and they are the same answer, then this thing had to have the same answer also. Okay, that was a lot of pronouns in there, kind of. So, all right, so here, this is how it goes. We're going to start with a function that we know where it is. And typically, these are for trig, and this is called the sandwich theorem. The idea is you're squeezing, like squeezing between bread. These are for trig functions, specifically for sine and cosine, and it's related to those because we know sine and cosine, the range is always between -1 and 1. Always. Okay, so here we go. We're going to start with that function, and the fact is no matter what is here, sine is still going to have answers between -1 and 1. So that means that I can even do sine of 1 over x, and it'll be between -1 and 1. Okay, now that doesn't look exactly like what I have yet, and so what we're actually doing is we are building this thing and then ultimately building this whole thing piece by piece. It's like we're making a sandwich, and ultimately our hope is that what's on the left side and the right side of all of this will match. Okay, so let's just keep going. Okay, so I started with just sine. I knew it was between -1 and 1, and it really didn't matter what was here, so I made it what it was here. Okay, and then I'm going to put this x in also. Now, in effect, I'm not just putting it in, I'm multiplying all three sides by x. Okay, so when I multiply the left side by x, it becomes -x, or opposite of x if you prefer. In the middle, it's x sine of 1 over x, and on the right, x again. Okay, now again, this is just to remind me this is the last slide for this video. Little stop guy, he's cute. All right, so now I'm going to do the limit of all three sides. So the limit, as x approaches 0, of the opposite of x, the limit, as x approaches 0, of all of this, and the limit, as x approaches 0, of x. Okay, and then I'm going to do those limits. Well, I can't really, quote, do this limit, because that's the whole goal of this. So I'm just going to write that down. If I'm going to try and find this limit through this process. Okay. Now, this thing, well, -x is continuous. I can find that limit by just dropping a 0 in there. What's the opposite of 0? Sweet. Well, I can do that here also. What's the limit as x approaches 0 of x? Well, x is 0. Oh, no, that's 0 also. Okay, now what this thing says is if these two limits are the same thing, then the answer for the limit I was really looking for is that number, is that value. Okay, so let's pop back down there. Well, notice these two are the same. So in other words, the limit as x approaches 0 of x times the sine of 1 over x, it's between 0 and 0. Well, if it's between 0 and 0, it is 0. That's it. Rewind all you need, pause all you need. See you in class.